Hi everyone. So in today's video, we are going to start MLflow Model Components part. So in the last few lectures, we have covered the tracking part, tracking component part on the MLflow, and now from today onwards, we are going to cover the models part inside MLflow. Okay. So inside model components, there are few components that we need to understand. The first one is storage format, the next one is model signature, and more two are here, model API and flavor. So let me explain this storage format first. As you can see, I have written few of the lines here. So standardized model packaging. MLflow stores models in a structured format known as the ML model format. I'll show you these all things, okay? So MLflow stores models in a structured format known as ML model format. This includes the metadata like model type, framework and dependencies, and the actual serialized model artifact such as pickle file for scikit-learn or .pt file for PyTorch. Multiple flavors for interpretability. MLflow supports different ML model flavors, allowing a single model to be used in across different environments. For example, a model saved in MLflow.pyfunc format can be loaded into different ML frameworks or deployed via REST APIs. The next is storage in local, cloud, or remote repositories. MLflow models can be stored in local directories, MLflow tracking server, all cloud-based storage such as S3 bucket in AWS, Azure Blob in Azure, or in GCS in GCP for better scalability and accessibility. Okay, so let me show you the storage format first, like what all things I am talking about. So this is the one of the experiment that I ran in the last lecture. If you haven't seen that last lecture, please watch that lecture. Okay, so this is the one of the run under that lecture called exp4. Okay, and inside that run I came in this artifacts part, and this artifacts contains all the information. I hope you can recall, just few seconds ago I have mentioned about this ML model which contains the metadata of all the models. Okay, not all the models, I mean whatever model we have trained on the specific run, right? So as you can see, it's containing the artifact path. This is the model. Inside the model folder we have the this all metadata. Now what kind of flavor we have? It was a Python function. What kind of environment we have? See, these things can be used to reproducibility. So if you want to reproduce the same output, then we can use this all metadata to reproduce the same output. Okay, that's why we need this kind of metadata. Now coming to the flavors part. In this flavors we have Python function, and that under that we have a env and the environment. We have the conda YML file. What is it, conda YML file? If I click on this conda YML file, this all the dependencies are mentioned. Okay, so if you're using anaconda to do this code run, right, if you are create a virtual environment, so what kind of dependencies you need, it's all are mentioned here. So if you are doing conda, if you are using creating any Python environment using conda, so this is how, by installing these dependencies, you can reproduce the same output that I got when I was running that code. Okay, now if I again come back to ML model, you can see virtual env python env.yml. If I go to this python env.yml, I can see if I want to create a virtual environment using Python, not from anaconda. Okay, so these kind of dependencies are required. See, this is referring these dependencies, as well as it is referring some requirements.txt that we need to install. So this is the requirement.txt that we need to install to run our code properly. Okay, next, model path, model.pickle file. So this is the model.pickle file which was the model that we trained, and it was logged by MLflow. Okay, now loader module. What kind of model we trained? We model MLflow.sklearn type model. Okay, now the predict function, the using predict we can call that predict function, but that was not the in our code. Okay, so you can ignore it as of now. This is the Python version. Now this is the sklearn model that we trained, right? That is, it is mentioning that the pickle format, it was a model.pickle file. Serialization format, it was a pickle file, so cloud pickle is there. And what was the sklearn version? Version was 1.6.1, that is also mentioned. Model version is also mentioned. Model size in bytes are also mentioned. Some model unique ID and run ID, these all are mentioned. Okay. Now, save input example info. Okay. So what kind of input data we need to pass? That we can find inside input example.json. So if I go into this input example.json, you can see the column, the data. So this all I showed you last time, the last video, right? But this all are storage part. All inside the storage only we are keeping all of it. Okay, that's the storage format is working here. It's keeping all the metadata of that run. Not only that run, maybe multiple runs, maybe multiple experiments, all are stored inside this storage, and these all are this example of those storages. Okay, now you can see the pandas orientation, you can see the serving input path. So if I go there, so how we want to serve our model, when serve in the sense when we try to deploy that model somewhere, and how do you send some input to get some output. So these are the ways how we can send the input and we can get the output from the model. Okay. Okay, now this is the type, it was a data frame. Okay, and this is the model signature. Signature means what I told you, I told some information about the model. What kind of information? Like the input of the model, the output of the model, this kind of information. As you can see, this is the inputs, this kind of inputs we had. And what kind of output we had? We have an output called a tensor kind of output, or I was having a data type called float64. Okay, this is how it is showing it up now, and this is some UTC time it is showing it. Okay, so this is the storage part. Okay, this is the storage part that I was explaining to you few seconds ago. So this is the example of the one of the storage, how it's, what kind of data it stores. So this is the good example of that storing thing. Okay, so let's go back to our PPT. Now we'll talk about this model signature. Okay, so describes input and output. It tells what kind of data the model expects as input and what gives as output, helping to avoid errors. Can be auto-detected or set by user. It can be guessed from the training data or manually set to make sure the model gets the right kind of a data. Work with different data types. It supports number, text, unstructured data like tables and arrays, making it useful for different types of models. Okay, I will explain to you this model signature in more detail because there are many things that I need to explain to you regarding this model signature. I will explain to you. So the next is model API. So model API allows using models through an API. Through an API, you can easily access your model. You can send the data, you can get the prediction from the model. The next it supports synchronous and asynchronous request. And the last is real-time predictions. You can do real-time prediction, you can do batch processing, all you can do very easily. The next is flavor. See, standardized model representation. MLflow defines several standard flavors that all its built-in deployment tools support, such as the Python function that I showed you before. Python function flavor, which describes how to run the model as a Python function. Then is framework specific flavors. MLflow provides built-in flavors for various machine learning frameworks, including scikit-learn, TensorFlow, PyTorch, and XGBoost. For example, the MLflow.sklearn that I showed you, it's a flavor, allows loading models back as a scikit-learn pipeline object for use in code that is aware of scikit-learn. You can also have custom flavors. Beyond the built-in flavors, MLflow allows the creation of custom flavors to support additional frameworks or specialized use cases. Okay, so let's see what we have in the next. Okay, so before going into the next, let me explain you a few things. First of all, the model signature. So I'm in the documentation of MLflow, and these guys are mentioned about model signature. Let me read it out first. The model signature in MLflow is integral to the clear and accurate operation of models. It defines the expected format for model inputs and outputs, including any additional parameters needed for inference. It's self-understandable, right? Now this is the one a good diagram that these guys have mentioned. Why this important, right? First, we need to understand that model signature exists, but why do we need it? See, using a model that has no input example or signature. So you load the model. Okay, you load the model. Now it's a super awesome model. But what kind of output do you send to it? Is it a list? Is it a dictionary contains the string elements, or is it a list kind of a list? So how do we know that what kind of input we need to pass to get some output, right? That we don't know if we don't have any model signature in our scenario, right? So logged model experience using input example and signature. So if we are logging the model as well as we are putting the model signature of it, that means the input example. If we put that, then it will check the input example. Okay, it contains something called list dictionary kind of a thing. Then it will verify the signature that okay, is it correct or not. Then accordingly to load the model and then we get the output, right? That's why we need to know the model signature. That's a very good example provided by this MLflow people in their documentation. Okay, fine. Now let me explain to you a few more things. So in the model signature, we have two types of model signatures. Okay, as you can see, these guys are mentioned. MLflow supports two primary types of signatures. The first one is column-based signature for tabular-based data, and a tensor-based signature for tensor data. Okay, and now let me read it out a bit about it. As you can see, column-based signatures are commonly utilized in traditional machine learning models that require tabular data inputs such as a pandas data frame. These signatures consist of a series of columns, each potentially having a name and a specified data type. And the type of each column in both input and output corresponds to one of the supported data type. That we will see what kind of data type is. And columns can be optionally named. Okay. So what kind of data type? String, integer, long, float, double, boolean, data type. So this kind of data type it supports. Okay. And now if we go back to our code, okay, so this is the one of the code that I have prepared for you guys. It is not that I prepared explicitly, it's mentioned in the documentation only, but I have made some few modification in this code, okay, to make you understand about it. Okay, so right now as you can see I am importing these things: pandas, sklearn, random forest and MLflow. And this is, let me just close all of it as of now because I need to explain to you a few things. Okay, so this is the example of column based model signature. Okay, this is the example of column based model signature. Okay, so as I mentioned, I have imported these libraries. I'm loading an iris data set again. I'm converting that into a data frame. I am calling this random forest classifier. I am setting the tracking URI because in my case, as you can see, this URI is hosted here, okay, already. So that is why I kept the set tracking URI. Then I have set an experiment. I gave the name of this experiment called signature exp. This is the experiment name. And now I am starting the MLflow. I am fitting the data. Now this is the input example. This is a column based model signature, guys. This is the input example of column based model signature. Okay, this is the input example. I am logging the model. This is the model. This is the name of the folder. And this is the input example. Again, guys, I am again telling you it's a column based model signature example. Okay, now if I do CLS and if I run this code, python column based model signature.py, the code will run now. Let's see. So we got some okay, so let me do one thing. Okay, let me change the name because previously I ran this experiment, okay, and that is why it is showing like this, and I have removed that experiment, okay, before showing you, and that is why it was causing this issue. So let me rename it. I'm giving a name like signature exp1 as of now, okay, and I'm running this code. Now the code should run now. It's running it now. As I have told you guys in the last lectures also, if you ignore these warnings, okay, as of now it is not required. See, this does not exist, that means it is creating a new experiment, okay. So it has created a new experiment. If we go back to our code now, And if I come refresh the screen, can you see signature exp1? If I click on this, can you see one run has created? And now if I click on this run, now I am in this run. Now if I go to artifacts, can you see the model signature here? Inputs, what kind of inputs we have? These are column based model signature, guys. Again I am telling you, it's a column based model signature. What it contains? Input, sepal length, sepal width, petal width. What kind of output we record? We record an integer kind of output. So we have specified the input, we have specified the output. So this is the column based model signature example. Okay. So now if I go back to my code, okay, and if I run now this tensor based model signature, I'm renaming it TensorFlow model signature. Okay. So if I run this now, this TensorFlow model signature, yes. So I'm running this tensor based model signature. So this is a tensor kind of a data. If I show you the code, what you can see, I am loading the MNIST dataset. I have created some layers, okay, some neural network. Then I am using sparse categorical cross entropy as a loss function here. Then I am compiling the model and I am running the code again. As you can see, it is running in my laptop. So this is running right now. So we should be able to see this experiment also inside our MLflow experiment, but it is not tensor based model signature. It is not a column based model signature. As you can see, it ran successfully. If I go back to our code again, and if I click on the signature ext1 again, can you see 40 seconds ago this new experiment is created? Let me click on this one. I am on the page here again, and if I click on this artifacts now can you see the inputs? So in our scenario, this is a tensor based model signature example, guys. So there, as you can see, I have this kind of tensors, okay, and I have output like this, okay. So this kind of input, this kind of outputs we have. So this is a tensor based model signature example. Okay, guys, I hope you understood. So I think we are good in this part. Okay, now let us understand about signature enforcement. Okay, so if I go back to the documentation again, okay, and if I go above, these are signature enforcement. MLflow schema enforcement rigorously validates the provided inputs and parameters against the model signature. It raises an exception if the inputs are incompatible and either issues a warning or raises an exception for incompatible parameters. So if you are sending an input, if that is correct, then it's fine. But if that is not correct, you will get an exception or you will get an error. You'll get an error, okay, and that's what we call signature enforcement. We validate the input. Whatever inputs we are passing for the model, we'll validate that. That's the job of signature enforcement here. Okay. As you can see, there's a good diagram shared by MLflow. If we come below, this is the using signature enforcement and what signature enforcement is doing. If we understand here using signature enforcement part, load model that has a, let me just zoom it first. I think you'll get a better visibility than if I zoom it. Yes. Okay. Using signature enforcement. Load model that has a signature defined. This is a signature kind of a thing. We are loading the model using pyfunc. We are calling the predict. When we are calling the predict, we are passing the data here, right? This is the data we are passing here. Input data signature validation, parameter signature validation. We are passing the data as well as we are passing the parameters. Okay. This is the input data signature validation and this is the param signature validation. Now we have checks pass. Okay. If parameter validation and input data validation is passing the case, then it will submit to the model. If it is not passing the case, it will raise an exception. Okay. Now, if I zoom out a bit, okay, if I zoom out a bit and if I go below, okay, let me just, I think I lost it. First, yeah. Okay. Now we have two kind of enforcement here. One is name ordering enforcement, another one is input type enforcement. Okay, and instead of reading from here, I have pointed out 2-3 lines. There I'll explain what are these enforcements are, and instead of reading out this documentation page, I have created one PPT where I have noted down few points. That points I will discuss and I'll explain you about these enforcements. Okay. Okay. Now let me explain to you this name and order enforcement. What it does, input matching. MLflow checks all required input fields specified in the model signature and present in the provided data. If any required fields are missing, an error is raised. Next is handling extra fields. If input data includes additional fields not defined in the signature, MLflow ignores these extra fields during inference, focusing only on the expected inputs. Next, flexible ordering. The order of the input fields in the provided data does not need to match in the order in the signature, as long as all required fields are present and correctly named. Okay. Next is input type enforcement. Type checking. MLflow verifies that the data types of the inputs match those specified in the model signature. And next is safe type conversions. For column-based inputs, example data frames, MLflow performs safe lossless type conversion when necessary. For example, converting an integer to a float is allowed, but converting a float to an integer is not allowed, as it may result in data loss. So this kind of validation does by these two kind of enforcement in our scenario. Okay. So now let me go back to the code and let me explain you a few more things. If you can recall, guys, in the last lecture, we have used auto log, right? Where we are logging the model signature and everything, right? But it was a auto log that we were using to get it done. But now what I do, I want to show you how we can use model signature manually. Like instead of depending on auto log completely, that was doing everything in our scenario. Instead of that, let's do auto logging, not auto logging, sorry. Let's do the model signature in our way. Okay. So let me just show you first how you are going to do that. So if I create a new py file here, let's say model signature manual. So first I will show you some manual way to create the model signature. Then I will show you another method called infer signature. Okay, that is a method created by MLflow that will automatically infer the signature of any model. Okay, so first I'll show you manually that how it works. Then we will go on this infer signature example also. So for that, first of all, what I do, I will go back to our last discussion, right? This one. I'll copy the whole code. I'll paste it here. Now, here I was calling auto log, right? I was calling that auto log. I will just remove this loop and all because this is not required now. I don't want to do these things. So I'll just shift tab to this. I'll give some estimate as of now 12 and 12, whatever I want to pass now. And now what I do, few changes I need to do. What changes I can do here? Let me check. Let me first do this one. Okay. 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 So first of all, as you can see, is the auto log. We kept log input examples true. It was automatically saving the model signature. Now I don't want that. So I am removing model signature. I am doing the false log input example equal to false. Then log model equal to false. Okay. I'm trying not to do the log model. I'm trying not to do the log input examples. I kept everything as false because I don't want autolog to do it. I will do it manually. Okay. So now to do it manually, I need to import few things. Let me import those. So from MLflow dot models dot signature import model signature. Okay. Other one is from MLflow dot types dot schema import schema and call spec. Okay, my bad. Okay, we are good here. Now let's come below. Let's do something here. Let me just. Okay, okay. So what I do now? First, I will try to pass some input data details. I need to pass some input data details. Okay. Let's say input data is like input data equal to. Okay. So I need to check the data set. Okay. First of all, because I forgot how the data set was looks like. Okay. So this is the data set, right? So I kept gender. Um, let's close all this one because it's not required. Okay. So I'll have to check what kind of data set we are using right now. And I think I was not doing any scaling here, right? Yeah, I was not doing any scaling here. That looks okay to me. Okay, I was not doing any scaling here, so that was okay to me. If I come below again, I will pass the input data. So first one was the gender, right? If I think it was gender only, right? Okay, gender, and then I will pass some input examples. Hold on, I think I need to this back. I think I need to import numpy for that. Okay, numpy is imported already. So I'll do np.array. Okay, and it will contain some details like male, female, right? Female, male. Is kind of array are there. The next what we had this race ethnicity, right? The race ethnicity we had. Again pass the input array for this numpy array. Okay, I think all automatically is coming for me. Just let me check. Yeah. So where race and ethnicity? Yeah. So group B, group C, group D. So this kind of race ethnicity we had. These are parental level of education. Again, this is an example of parental level of education, and this is the example of lunch. Okay, after lunch, what we have? Test preparation course. Okay, let me give that also. Test preparation course. Okay, then numpy array. What kind of data we had? Test preparation course. None completed. Okay, okay. So this kind of data we had. Next is math. What was the name? Math score. Right. Let me just copy it from here. Paste it here. Okay, so this is automatically suggesting by my copilot. Okay, so these are the values that we had. So these are the value examples. Okay, for our model, it was an integer type, so that's fine. I think last one was reading score and writing score. So let's put that also. What was the name? Reading score, right? Okay, reading score np.array. So now I need to pass some values. Same type of values we can pass. Like that's normal. I am passing same kind of values as of now. Next is writing score. Okay, writing score. Okay, so this is the writing score. So this kind of input data that we had. Okay, now what I do, I have got my details here. Now what I do MLflow dot. So I am using sklearn model. So dot sklearn dot log model. Okay, log model. I'm logging the model. So what is the model name? Model name was or I'm calling the model. Okay, model name was model. So model, I'm passing the model. Then I'm passing the name. Let's say RF model. Okay. Then what I'm doing, I'm passing the signature. So signature equal to uh, signature. Okay. Then I'm passing the input example. Okay. Input example equal to input data. This is the input example that I had, right? Now I'm done, but signature is not defined. It is telling. Okay. See, I have defined my input data and I have called the log model. I have given the model, I have given the RF model name. Then I am passing the signature. What kind of signature, that I will explain. And the input example. The input example is the input data that I have passed here. Okay. But now, what is the signature thing? Okay, let me brief it on top. Okay. So in the signature example, first we need to mention. Okay. So let me pass the input metadata. Okay. Input metadata equal to, I'll open a list. Then what I pass, I'll pass the name. The name is gender. Hold on, gender. Then the type was string. Okay. The next was name, race slash. I must copy it from here directly. Race and ethnicity I need to pass here. Okay. Then the type. The type is again string. Then parental level of education is the name. Sorry, name. Yes, is the name. And then the type. Again, it's a string. Hold on. Then again name. I need to pass this parental level of education. Lunch. I need to pass the lunch. Then type. It's a again string. Then yeah. Test preparation course. It was string. Math score integer, reading score integer, writing score integer. See, you got all of it, right? And what kind of output data we had? Output metadata. Output meta data equal to type. Okay. So now let me define the type. What are we trying to predict in our scenario? If we go back to our code, if we go back to our any code, maybe this code only, we are trying to predict the math score, right? And what math score data type is? It's a integer data type, right? So that is why I need to pass integer. Okay. Now math score is a integer type output, right? That means I cannot pass this math score in the input metadata. right? I cannot pass that, right? I cannot pass that in the input metadata, and I cannot pass that match score here also, right? Okay, and now I have defined the input metadata, I have defined the output metadata. Now I'll define the input schema. Okay, input schema I have imported already. Now what I do, I will run a loop for call in input metadata. Yes, I run a loop in the input metadata, then I get a call spec here. I have specified the columns. Okay, so I'm taking the type. See, this is the type, right? I'm taking this type and the name of the column name. Okay, I have passed this the input schema. I need to pass the output schema also. Output schema. But now what how I need to pass it? Need to pass this way for call in output metadata, not input, output. And this type is only the name is not required. Okay. So for call in metadata, I am telling the call type. Okay. So I define the call metadata. I have defined the input signature, input schema, output schema. Now I'll get the signature. Signature equal to model signature inputs equal to input schema and output is equal to output schema. Okay, and now I need to change this. Cannot be input data. Okay guys, it will be this input metadata. By mistake I kept here. This will be input metadata. So this looks good to me. Now I'll do a new experiment, signature new, because I need to show you in a new completely new experiment. So let me do signature new, uh, signature new. Now I run this code cls. Now I run this code python model signature another py. Now the code will run automatically. Gets running. We got a auto log, got an unexpected keyword log model. Okay, let me check if it's wrong or what. For the auto log. Okay, there's a parameter called auto log. Let me just still check MLflow dot auto log parameters. And maybe passing something wrong. Let me just Google it in front of you only. So this is the auto log. Let me check auto parameter is contained. Auto logging. This automobile. And I go inside auto logging. Okay, the auto log. Okay, log models and log model signatures. Okay. So it will be log models. Another one I forgot to do, log model signature, because this is also coming as true. If I don't make it false, it will still create the model signature automatically. I don't want that, right? So I'll make it false this also. She should not do it automatically. Okay. So it looks good to me now. Let me just run this code again. I should not get any error. It's running now. Okay, it's running properly now. Okay. So this is the run name. Okay. If I go back to my code and if I click on this one, This is a signature new is created, and this is the experiment. If I click on this experiment now, not experiment, click on this run now. Now if I go to artifacts, can you see the inputs? Gender, parental label, output is integer. So now we are able to do it manually. Now we are not doing it using MLflow Autolog. We are doing it by our hands. Okay, completely manual process. But do you think it's really easy that I did? Like it was taking a hell lot of time, right? I need to write this many things. Like, can you see? I need to write too many things. This metadata schema, signature, input data, then I'm logging the model. It's like a hell, right? But the good news is that you don't have to do this much of hard work. I just wanted to show you how you can do it manually, but there is another way. Model signature infer.py. Okay, I'll copy this code only from here. Let's paste it here. But instead of doing this many hard work, I will call another method called infer signature. Okay, now I have called this model, right? Now what I have to do, I have to come below. Let me just comment all this one. Let me just comment all this one. Not required. Okay, so what I do, I'll do signature equal to infer signature. Infer signature. I'll call this infer signature. Then what I do, um, this is the okay. So this is the wipe rate. These are prediction is happening, right? We are doing on the testing data, right? So I'll copy this one. I'll pass that here. I'll pass in the testing data, and I am passing the prediction. Wipe rate. I am passing the prediction. Okay. Then I am passing the input metadata again. Input metadata again. Okay. Now what I do, I'll do columns np.array x test dot columns. Next is data np.array x test dot values. We are taking the columns, we are taking the values, right? Now same thing we need to do. Let's comment this one also is not required as of now. So input metadata, things are same. But now just to prove you I am doing right thing, I am doing new one. So it will again create a completely new experiment. Inside the new experiment there will be a completely new run. Okay, so that you will understand things are working. So instead of model signature manual, model signature infer. Okay, I'm running this code now. Okay, it's running. Let this one run now. Okay, it's done. Now if I go back to my page, click on this, new one is created. This is the run. Click on this run. I'm in the run now. I go to artifacts. Can you see the inputs? Can you see the outputs? It's showing float in the scenario, but it's fine. But yeah, can you see it now? It's happening, right? Now I've showed you two ways how you can create your model signatures, right? So I hope you guys have understood this whole process. So that's all I wanted to show you in this video.